in P7 and P8, we dealt with writing the equations, telling what happened to the function when we added something or subtracted something on the inside or outside of the equation. And then we took and just went and dealt with the equations. Now we're going to actually deal with the graphs, and we're going to want to graph these. And so the first thing that you need to decide when you do these problems is you need to decide, what is it going to look like? Okay, what is the parent function? That's the question. So the parent function is the first thing you want to find out. Okay, and the parent function for this one, for number 1, or the first upper left one, is linear. Okay, the parent function is linear. And then second thing you want to find is the transformations that happen. So I took that linear function and I now have a -3 at the end. Well, -3 means that I'm going to move it down 3. Well, you already know how to graph this, but I want you to think of it in terms of this parent function and transformation idea. I know that this is going to start at down 3, and it's going to go up 1 and right 1, just like a normal linear y equals mx plus b graph. But what I want you to think about is that this is just a straight line that transformed, went down 3. And so it started as this straight line idea, well, sort of straight line, that just went down 3. That's all that happened. And so then when I move on to the next one, I look for, well, what is the parent here? And this is a quadratic. Okay, this is quadratic. And to that quadratic, the normal quadratic, the parent quadratic, which usually goes like this, there, and there, which usually goes like this. This is what the normal parent quadratic looks like, a nice U shape. My transformation that I did, the transformation that I did is I took and I added 2 on the inside of the parentheses. Well, adding 2 on the inside of the parentheses actually is going to move this left 2. So I'm going to take this point and I'm just going to move it left 2. And I'm going to take and I'm going to make the same exact graph, except that every point is moved left 2. So I have the graph that looks exactly the same, except that I moved it to the left 2. Let's keep going down. I've got a square root, so the parent here is a square root. And so my normal parent square root looks like this. Then I took that parent function and my transformation is that I subtracted 2, and again it's on the inside, it's underneath this square root, so it's on the inside of this function. So my transformation of -2 actually tells me that I took and I moved this graph to the right 2. So I moved the graph to the right 2. That ends up looking like the same exact graph, just moved to the right 2. There's a cubic one right next to us, but we're going to go down to the next one here. This cubic one, the parent function, again, is cubic. And cubic in general looks something like this. So I want to know, what is my transformation? My transformation is I put a negative out front, so that's reflected on x-axis. And then I also added 1 on the inside. So when I add 1 on the inside, that means that I actually move left 1. So I have my normal graph that looks something like this. So it comes up, kind of bellies out there. That's what my normal function looks like. That's my parent cubic function. Now my transformation says that I reflected it on the x-axis. So now instead of this going down to the left and up to the right, it's now going up to the left and down to the right. And I moved it left 1. So this point moved left 1 here. Each point else then reflected across the x-axis, and I end up with a graph that looks like this. Okay, each point reflected across the x-axis. So this point, let's do this in green. This point right here reflected to down here. But then I moved it left 1 in order for it to continue with the rest of the transformation that happened. And then finally the last one here, my parent function, let's try to stay consistent. My parent function, it is an absolute value. My transformation is that I have the negative out front, so that's reflect on x-axis. Then I have a +5 on the inside, so that +5 actually means that I'm going to move it left 5. So my normal parent function looks like this, keeps going up 1 this way, up 1 this way, a nice little V shape. I'm going to reflect that on the x-axis, and so if I reflect that on the x-axis, every point then now is reflected and it looks like it's going down. Okay, it's that V shape upside down. But then I need to move this all left 5, so 1, 2, 3, 4, 5. Every point is going to move to the left 5, and my graph actually ends up looking something like this, with a V shape out here. Okay, upside down and moved left 5. And you can check all these things by typing them into your graphing calculator as well. If you have a graphing calculator, you can put all this stuff in and make sure that your graph looks the way that it's supposed to look. Absolute value is under the math button. So go under math and then look for ABS. That will allow you to put in an absolute value. If you have any questions about how you do that on the calculator, please ask. We'll stop this video with the work that we've done in a longhand version.